Hello everyone. Assalamu alaikum. I am Najmul Hassan Oyan from Group 17. Today our assigned chapter is extracting information from the text. To extract information from the text, we in the concept map we will show how the we can extract information from any given text. So let's get started. So first of all, for the given data, we will provide that our first step will be to check whether our data is pre-processed or not. Like the machine learning, if it is not pre-processed, then it will go to the no section, and there are three steps. And those three steps are removing stop words, removing stemming words, and removing lemmatizing words. We often show that stop words in the sentence, and you usually know what is the stop words look like. And the stemming words are words that have been reduced to their base form. This is done by removing inflectional ending from the words. And lemmatizing words is a more sophisticated way to reduce words to their base form. Lemmatization takes into account the context of a word so that words with different inflectional endings can be reduced to the same lemma. And after these three processes works parallelly, we can see that stop words and stemming words and lemmatizing words. After that, it will go to the this connector. If our data is pre-processed, then it will go to the straight to the tokenization, and if data is not pre-processed, then it will go to the it will complete these three steps, and after that it will go to the tokenization. So now we will talk about the tokenization part. So we actually know that if we use the token in our daily life, and token means that there is individual collection of things, like if there is a big things, and if we can divide the big things into small things, and those small things is called as token. So in the NLP, tokenization is the process of breaking a text into smaller units called tokens. Those tokens can be words, characters, or subwords. Tokenization is a fundamental step in NLP because it allows NLP algorithm to process text in a more efficient and meaningful way. Word tokenization is the process of breaking a text into individual words. This is the most common type of tokenization and is most often used using a simple rule-based approach. For example, let's say I love NLP. And after tokenization, it will break down these three words into three. It will break this sentence into three individual tokens such as I, love, and NLP. So after that, after tokenization, here comes the here we can see that there is a collection words, and after that, after tokenization, for example, I have said earlier that I love NLP, collection of individual words. Now it will process to the text extraction algorithm that is provided by in our system to do the tokenization part. And after tokenization, here comes parts of speech tagging. It is actually the process of assigning a part of speech tag to each word in a text. Parts of speech tags indicate the grammatical function of a word, such as noun, verb, adjective, or adverb. Parts of speech tagging can be used to improve the performance of NLP algorithms, such as that are used for machine translation or text classification. Here we can see that we will use text extraction algorithm. For that, we have to use text inside the text extraction algorithm. We have to use parts of speech tagging, where the every parts of speech will be individually will collect, and there will be also grammatical function of words. And after that, here comes entity detection and relation detection. I will describe entity detection with the relation detection as well. Entity detection and relation detection are important tasks in many NLP applications, such as question answering, information extraction, and machine translation. For example, in a question answering system, the entity detection task would be used to identify the entities in the user's question, and the relation detection task would be used to identify the relation between those entities. So entity detection and relation detection works parallelly as well. So with the help of relation detection and entity detection, we can identify those relationship with the entities. For example, he is a student. So we can find that he and student. there is a relation among them. Or for example, Barack Obama is an USA is a USA president. There means is a Barack Obama, and there is a relation between US president. So there is a with the entity, there is a relation detection as well. And here comes the chunking part, and chunking part will continue with will continue my mate Samiha Jubaida Alam. That was from my side. Thank you, everyone.
Hello everyone, Assalamu alaikum. I am Samiha Jubaidalum from CSE department. I will be discussing about the rest of the part of our topic extracting information for text. After relation detection, we will be using chunking. Chunking is also known as shallow parsing. It is a natural language processing technique used to extract meaningful information from sentences by grouping words into chunks based on their syntactic structure. Chunking typically involves identifying and extracting noun phrases, verb phrases, prepositional phrases, and other grammatical units. There are some techniques for chunking. These techniques are irrelevant interrelated and can be used in combination to extract specific information from text data. Noun phrase chunking Noun phrase chunking specifically focuses on identifying and extracting noun phrases from sentence. A noun phrase consists of a noun and any modifiers such as adjectives, determiners, or prepositional phrases that are associated with it. Tag patterns. Tag patterns refers to the patterns or sequences of parts of speech tags that indicate the structure of a chunk. POS tagging is the process of assigning a part of speech to each word in a sentence. By analyzing the POS tags of con- constructive words, tag patterns can be identified that correspond to different types of chunks. Chunks with regular expression. Regular expressions are powerful tools for pattern matching in text. In the context of chunking, regular expression can be used to define patterns that captures the syntactic structures of chunks. These patterns can be applied to sentences to identify and extract chunks based on the defined rules. Regular expression provide a flexible and effective and efficient way to define chunking rules based on POS tags and their patterns. After working with three of the processes in chunking part, we will go to name entity recognition. Name entity recognition is a natural language processing task that involves identifying and classifying name entities in text. Name entities are specific words or phrases that refers to real world objects such as persons, organizations, locations, dates, quantities, etc. NER name entity name entity recognition requires Name entity aims to identify and extract these entities from unstructured text. If name entity recognition requires, then it will go to identity, identify name entities and refer to specific entities. So identifying named entities. The first aspect of NER is to identify named entities in the text. This involves locating words or phrases that represent specific entities. After identifying named entities, it will go to referring to specific entities. Once named entities are identified, they can be referred to using their recognized labels or categories. The relation the relationship between identifying named entities and referring to specific entities is that name entity recognition provides the means to recognize and categorize entities in the text. Once identified, the specific entities can be referred to using their associated labels or categories. This process of identification and reference allows for the extraction of relevant information from the text by focusing on specific entities of interest. For example, in an application where you want to extract information about companies, name entity recognition can identify and categorize the names of companies mentioned in the text or organization entities. If name entity recognition is not required, then we will go to relation extraction. Relation extraction is a natural language processing task that involves identifying and extracting the relationships or associations between name entities mentioned in text. It aims to uncover connection between entities and represent them in a structured format. Relation extraction is closely related to name entity recognition as it relies on the extraction of named entity before extracting relationships between them. Once named entities are recognized, relation extraction focuses on analyzing the contextual information around these entities to determine the nature of their relationships. In conclusion, we can say information extraction system aims to search through extensive textual data to identify specific types of entities and relationships, extracting valuable information to populate well-organized databases. That's all from me. Thank you.